Have you ever wondered why some people seem to gain muscle and strength effortlessly while others struggle despite putting in the same effort at the gym? The answer lies deep within our DNA. In this video, we are going to dive into the fascinating world of genetics and uncover how your unique genetic makeup can influence your response to exercise and training. Whether you're a high responder or a low responder, understanding this can transform the way you approach fitness. Genetics absolutely plays a significant role in influencing your response to exercise. This can affect everything from muscle growth and strength gains to endurance and even recovery rates. Hi, my name is Mikhail St Catherine. Please give the video a like. If you have any questions during the video, drop a comment, or if you have any thoughts, also please drop a comment, and be sure to subscribe for more videos like this in the future. We will be taking a deep dive into how genetics affect exercise and training outcomes. Okay, team, let's get into it. Buckle up. This is going to take a little while. Obviously, we're calling this parent selection. It's killing your gains, bro. Right, there's no way I can remember all of the information in this presentation, so this is why we're going to present it like this, and then we're going to dig into it right now. And then obviously if there's any points that I want to extrapolate, I will do so. Right. Does genetics influence your response to exercise? This is the big question. In my personal experience, let's see if I can move that out of the way. I can. In my personal experience, how genetics affects exercise and training outcomes is an area that I think most people don't really talk about. It's been shown in a number of studies that if you give the exact same training plan to a group of people, it can lead to widely different responses. Of course, there'll be factors influencing the outcome like nutritional habits, training experience, effort, age, and sex, right? Personally, I have realized I am, and always have been, a somewhat of a hyper responder, and not necessarily because of physical adaptations to exercise, but I always felt confident that I could learn physical skills rather quickly and often quicker than people around me. At school and amongst my peers, I always was one of the best at any given sport, depending on how long I practiced it. For example, even in my later years, I started Muay Thai last year, and I've always felt like I could pick things up quite quickly, even though it is quite a complicated sport and a complicated skill. All right, a little fun fact. I started walking at 7 months old and my sister at 8 months old. The standard is 10 to 18 months. So both my sister and I started walking incredibly quickly, and she also has a genetic skill for picking things up quickly. And as you can hear, we can just see like a little conversation between my mom and myself. Oops, sorry. Yeah, let's see if we can get rid of that. Perfect. And I was asking her, to remind me when did I start walking again. And it's at 7 months old, lols, little giant. And as if we can see from research, the usual starting age is about 10 to 18 months old. So somewhat rather quickly. And this is obviously a factor in how quickly children can pick things up and how quickly they pick up sports, and even in education as well. Everyone's kind of got their genetic traits that lead into certain skills. This was one area my mum did highlight to me, that I picked things up fast so others would get jealous, and she tried to make me aware of this from a very young age. Now, this is not to say I didn't work hard at those skills, because I generally learned quickly. I always felt the need to push myself and get better quicker. And this is often a trait I noticed coaching people. Those with somewhat better genetics often push themselves more than those with lesser genetic abilities. I think it's because those on the lower end of the scales seemingly must work twice as hard, and thus it becomes an unmotivating endeavor. They take much longer to see results. And this is why I have always sought to increase my skills and knowledge as a coach to deliver results for those not so genetically blessed, using exercise science and nutrition science. If you develop a system, it will work for both low responders well, if you develop a good system, effective system, it will work for both low responders and high responders. The only difference is at what speed. And this photo of the on the right is what I would consider my leanest, most shredded self. It's quite difficult to get back there now. I'd have to eat no food basically. But back then I think I was maybe 90 kg, maybe a little bit less. At the moment I'm 94 kg and I've been up to 105. Okay, let's explore genetics' role in physical traits. So genetics is a study, or is the study of heredity and the variation of inherited characteristics. So we must define what genetics is first before we can start to look at what genetic traits improve certain characteristics or physical characteristics. It focuses on how genes, which are segments of DNA, influence the development and functioning and behavior of living organisms. Genes are the basic units of heredity and carry instructions for making proteins, which perform most life functions and form the structures of cells and tissues. So what are the traits, genetic physical traits? Inheritance. Physical traits such as height, eye color, and skin color are inherited from parents through genes. Each individual has 2 copies of each gene, one inherited from each parent, which combine to determine specific traits. Genetic variation. Variations in genes, known as alleles, can result in different physical traits. For example, variations in the MC1R gene affect skin and hair color, while variations in the FTO gene are associated with body mass index, BMI, and obesity. And very much so, you might not be able to influence the skin and hair color, but I'm pretty sure you can influence the FTO gene in terms of how much body fat your child may or may not hold onto. Gene expression, the process by which information from a gene is used to produce a functional product, such as a protein, is called gene expression. Differences in gene expression can influence physical traits and how the body responds to environmental factors, including exercise and diet. And this is a key area in terms of your lifestyle, your training, your diet. These all affect gene expression, which can be passed on to your children. Complex traits. Many physical traits such as height are influenced by multiple genes, polygenic, and environmental factors. For example, height is determined by the interaction of numerous genes as well as nutrition and health during childhood. Epigenetics. Environmental factors can influence gene expression without changing the underlying DNA sequence. This process is known as epigenetics, which can affect physical traits and how genes are turned on or off in response to various stimuli, including exercise and diet. And obviously on the right here, we have a study highlighting this, individual differences in response to regular physical activity. And the results show that, let me just move this out of the way. Several studies have shown marked individual differences in responsiveness to exercise training. For example, VO2 max responses to standardized training programs have ranged from almost no gain to up to 100% increase in large groups of sedentary individuals. A similar pattern, heterogeneity, I'm not going to try to say that, heterogeneity, I think, has been observed for other phenotypes. So when you say someone's a phenom, is because they have this very rare combination of genes and they're elite in terms of their response and skills. And we tend to see a lot of this in terms of race and sex, how well people can grow muscle, or how good they are at aerobic exercise, or how good they are at sprinting. These are all there's different races and genetic traits that determine how well you're going to do at certain of those physical activities. Data from the Heritage Family Study showed that age, sex, and race have little impact on individual differences in training responses. On the other hand, the initial level of phenotype is a major determinant of training response for some traits such as submaximal exercise, heart rate, and blood pressure, but has only a minor effect on others, VO2 HDL. The contribution of familial factors such as shared environment and genetic factors is supported by data on significant familial aggregation of training response phenotypes. There is strong evidence for considerable heterogeneity in the responsiveness to regular physical activity. Age, sex, and ethnic origin are not major determinants of human response to regular physical activity, whereas the pre-training level of phenotype has a considerable impact in some cases. So that's also really interesting because it's expressing how if you try to stay in good shape, you can change the way your children respond to training. Yeah. Familial factors also contribute significantly to variability in training response. So it's a rather complicated subject. Okay. And on the right here, obviously, we have some photos of some Chinese weightlifting academy children, and they're quite famous in terms of it's come from social media and lots of videos coming out about how the Chinese recruit their Olympians or their athletes. So, genetic influence on physical performance. Certain genes can influence muscle composition, cardiovascular capacity, and other aspects of physical performance. For instance, the ACTN3 gene affects fast twitch muscle fibers, which are important for explosive strength and sprinting abilities. Understanding the genetic basis of physical traits helps in identifying how genetic variation contributes to differences in physical appearance, performance, and susceptibility to certain conditions, enabling personalized approaches in areas such as fitness, nutrition, and medicine. This genetic base is something we see in sports team selection, and one area that comes to mind is the Chinese weightlifting team selection. They will literally weed out the weaker genetic children and are left with the cream of the crop, so to speak. These elite genetically gifted children go into their training system and eventually become Olympians. Of course, along the journey, those who cannot sustain the training intensity and regime will fall to the wayside, leaving the 1%ers to go on and compete at an international level. All right, let's dig into some scientific studies. There have been numerous studies investigating the influence of genetic variation on exercise response. The field, often referred to as exercise genomics, explores how different genes affect individual response to various types of physical activity, including endurance training, strength training, and overall fitness improvement. All right, these seagulls are going crazy this morning. Sorry, guys. Yeah. Key findings from notable studies. The Heritage Family Study. This landmark study focused on the genetic basis of responsiveness to aerobic exercise training. The researchers found significant genetic influences on changes in VO2 max, a measure of aerobic fitness, following a standardized exercise program. The study concluded that up to 47% of variance in VO2 max response to training could contribute to genetic factors. Right, so that's quite substantial, yeah, compared to all the other influences like age, sex, weight, ethnicity. And obviously, this is highlighted in the study on the right here. That finally, as described earlier, genetic component VO2 max trainability accounted for 47% of the variance, a heritability level compatible with estimates obtained in selection experiments performed in rats. Thus, in the aggregate, the sources of variation or correlates of VO2 max trainability explain 87% of the variance, as detailed below. Okay, guys, moving on. So the ACTN3 gene, research on the ACTN3 gene, which codes for protein in fast twitch muscle fibers, has shown that variations in this gene can influence muscle function and performance. Individuals with the R577X polymorphism in the ACTN3 gene tend to have different muscle characteristics affecting their performance in strength and sprint activities compared to endurance activities. Yeah, generally speaking, it's hard for someone to be good at both endurance and strength or explosiveness. It's usually a case that you will excel at one of those capabilities. And it's very rare for people to be like extremely good at both of those. The body just doesn't function that way, especially in the genetic makeup of the human. that we're talking about, right? So the ACT-N3 genotype is associated with human elite athletic performance. There's increasing evidence for strong genetic influences on athletic performance for an evolutionary trade-off between performance traits for speed and endurance activities. We have recently demonstrated that the skeletal muscle actin binding protein alpha actin 3 is absent in 18% of healthy white individuals because of homogeneity for a common stop codon polymorphism in ACTN3 gene. Right, some of these words, guys, I'm probably not going to say them, so forgive me. Alpha ACTN3 is specifically expressed in fast twitch myofibers responsible for generating force at high velocity. The absence of a disease phenotype secondary to alpha actin 3 deficiency is likely due to a compensation by the homologous protein alpha actin 2. So there's definitely like a trade-off here in terms of where the human evolved and what sort of climate may be an issue as well. However, the high degree of evolutionary conservation of actin 3 suggests functions independent of actin 2. Here we demonstrate highly significant associations between actin 3 genotype and athletic performance. Both male and female elite sprint athletes have significantly higher frequencies of the I think it's R5777R allele than do controls. This suggests that the presence of alpha actin 3 has a beneficial effect on the function of skeletal muscle in generating forceful contractions at high velocity and provides an evolutionary advantage because of increased sprint performance. There's also a genotype effect in female sprint and endurance athletes with higher than expected numbers of 577RX, heterozygotes, I'm not going to say that, guys, among sprint athletes and lower than expected numbers among endurance athletes. The lack of a similar effect in males suggests that the actin 3 genotype affects athletic performance differently in males and females. The differential effects in sprint and endurance athletes suggest that the R577X polymorphism may have been maintained in human population by balancing natural selection, which makes sense. Can't everyone be good at sprinting and no one good at endurance, right? It's kind of like the sleep chronotype issue where there'll be a segment of the population who prefer to sleep kind of like a middle zone, maybe like 10 to 6. There'll be a population that prefer to sleep early and wake up early, and then there'll be a segment of the population that genetically prefer to go to sleep very late, maybe night owls, and wake up late. And it's probably just a genetic evolution trait that we all can't be sleeping at the same time, because obviously we're susceptible to dangers then, yeah, as a human race. But obviously now in modern society, that's probably not so much of an issue, but we're still carrying those genetic traits. Okay, moving on. So the PPRG C1A gene variants in the PAR, I'm just going to call this the PAR gene, yeah, because that's a very long name, which plays a role in energy metabolism and mitochondrial biogenesis, have been associated with differences in endurance performance. So this is where there's those two mutations, so the actin and the PAR. So generally, I think they'll mutate towards one or the other variant. Individuals with certain variants of this gene may experience greater improvements in endurance capacity in response to aerobic training. Now see, in this table here, the group of Russian athletes, we can see how much the frequency of the PAR gene allele in 4 groups of Russian athletes stratified by elite status and in the group. Yeah, so in the strength of athletes, there's less variation or less difference between most of the people in there. So top people, elite, sub-elite, non-elite. And in endurance athletes, there's a greater difference and higher ratio of the gene. The aim of this study was to investigate the PAR7 and the PAR1 gene and the polymorphism on aerobic performance of elite level endurance athletes. This study was carried out on 170 individuals, 60 elite endurance athletes, and 110 sedentary controls. Aerobic performance of athletes and sedentary control groups were defined by maximal oxygen uptake capacity. DNA was isolated from peripheral blood using GeneJet genomic DNA purification kit, and obviously genotyping of the PAR alpha intro and the PAR 1, and obviously that's part of the name, I suppose. Polymorphism was formed by using PCR methods, and statistical evaluations were carried out using using SPS. Okay, let's just see what the main were. So we found statistically significant differences between athlete and control group with respect to PAR and PAR1 genotypes, respectively, and allele frequencies. Additionally, when examined for both the PAR alpha and PAR1 genotype distributions according to the aerobic performance test parameters, we found a statistically significant association between velocity time and maximal oxygen consumption. And PAR alpha and PAR1. So today, our knowledge first study in Turkey examined the alpha and PAR1 genome polymorphism in elite level endurance athletes. Our results suggest that the PAR alpha and PAR1 genes have a strong effect on aerobic performance of elite level athletes. And that all makes sense. You're always going to have the best of the best in an elite setting, or making it to an elite setting, having the best genes and the best mutations towards certain traits of those genes. Okay, scientific studies continued, and then obviously looking at the, I'm not going to say that, but the ACE gene, so angiotensin converting enzyme. Oh, I did okay there. The ACE gene has been studied for its role in cardiovascular and muscle response to exercise, and the ID insert deletion polymorphism in the ACE gene has been linked to variations in endurance performance, with the I allele being associated with better endurance and the D allele with strength and performance. So how does the ACE gene help athletic performance? The ACE gene provides instructions for making a protein called angiotensin converting enzyme, which converts a hormone called angiotensin 1 to another form called angiotensin 2. And obviously the 2 type helps control blood pressure and may influence skeletal muscle function, although its role is not completely understood. And also the results from that study, cycling exercise reduced muscle glycogen concentration, and then is tended to affect the AC1 allele genotype, showed a lower maximal RER, I'm not sure what that stands for, and a selective increase in serum glucose concentration after exercise compared to the ACE1, so the ACE1 and the ACE2 genotypes. Let me just have a quick skim of this really. Okay, so observations simply imply genetically modulated role for ACE in controls of glucose import and oxidation in working skeletal muscle. And ACE-DD genotypes thereby transit into a pre-diabetic state with exhaustive exercise, which relates to a lowered muscle capillarization and deregulation of mitochondria-associated metabolism. Okay, moving on. The myostatin gene, this one's quite interesting. I was reading a little bit more about this when I was looking into this information. So myostatin is a protein that inhibits muscle growth, right? Variations in the myostatin gene can affect muscle hypertrophy and strength gains in response to resistance training. Individuals with certain myostatin variants may experience greater increases in muscle mass strength from resistant exercise. So because the myostatin inhibits muscle growth, the higher your myostatin level, the less muscle growth you're capable of having, right? And then obviously if there's a mutation there, then you're able to increase muscle growth, right? And since this discovery has been at the forefront of muscle therapy because intrinsic mutations or inhibition of this protein by either pharmacological or genetic means result in muscle hypertrophy or hyperplasia. In addition to muscle growth, myostatin inhibition potentially disturbs connective tissue and leads to strength modulation. And this is quite interesting because I even probably noticed this within myself, that because I could respond quite easily to resistance training in terms of if I just train purely for muscle growth, I can grow it quite quickly, or have done. but we definitely have some connective tissue issues. I definitely have some connective tissue issues. I've had it since playing football as a 10-year-old. And sometimes you see this in athletes who express certain capabilities or higher capabilities, but they might be injured all the time. And there's often like a genetic trade-off in terms of performance and how resilient you are, right? And this diagram, this picture expresses that really well, I think. Okay, guys. Genome-wide association studies. So GWAS, let's call it for short, have identified multiple loci, which is the physical location of a specific gene on a chromosome associated with exercise-related traits. For example, a GWAS on physical activity levels identified several genetic variants that influence the propensity for physical activity and exercise adherence. That is very interesting. These studies highlight the significant role of genetics in determining how individuals respond to different types of exercise, but also how well that person can be adherent to physical activity, right? Understanding these genetic influences can help in developing personalized exercise programs that maximize benefits based on individuals' genetic makeup. And taking that capability for someone to genetically be adherent can determine when you're programming how much you can give that person, what you can give that person. If that person is going to lose focus, they're not going to be that adherent, then you can't give them like a very long session, too long. You probably have to give them a little bit more variation to make it interesting. But someone who is has a propensity to be physically adherent for over a long period of time, you can probably keep giving them the same thing and they'll still see like substantial improvements because they can be adherent to it. But I also believe this is probably something, a mental trait you can develop. Anyone can develop. Discipline is the word that comes to mind. Yeah. Right, let's kick on. Where are you on the genetic scale? Now we've got the science part out of the way, or the main scientific factors. A little bit of a look at that so you can start to understand some of the main players in that genetic influence going forwards. And if you're a coach, you can always probably can have a good guess and see how people respond, how they move, and what sort of exercises they're they're naturally good at. All right. So where are you on genetic scale? While genetics plays a crucial role, a holistic approach that includes proper nutrition, adequate recovery, and mental well-being is essential for optimizing training outcomes. By understanding the concepts of high and low responders and incorporating knowledge of genetic influences, like we just gone through, you can create a more effective and personalized approach to exercise training, potentially improving outcomes for a wider range of individuals. High responders and low responders are terms used to describe the variability in how different individuals respond to the same exercise training program. This variability can be influenced by genetic factors leading to significant differences in outcomes of physical training among individuals. And also looking at the graph on the right, muscle mass gains difference between individuals. Your average gainer will be in the middle here, and then you're always going to have some on the lesser end of the bell curve, which will be a percentage of the population. And then you're going to have the good gainers and genetic freaks and the phenoms on the right side of the bell curve, and will be a certain population of the certain percent of the population, right? But for most people, they're going to be somewhere in the middle here, yeah, and maybe leaning towards good. And that's obviously some people will lean towards hard gainers. Understanding this is key, in my opinion. Okay, so high responders versus low responders. Okay, bear with me, guys. Just gonna close this a second. Okay, just give me a minute. I'll open that back up in a minute. Okay, high responders versus low responders. Hopefully you can still hear me with the fan on. Okay. Definition of a high responder. What is that? Individuals who experience significant and positive changes in performance metrics such as strength, endurance, muscle growth, or cardiovascular fitness as a result of standardized exercise programs. So meaning you can give this high responder absolutely anything, very simple program, and they'll get significant positive changes out of it. Characteristics: greater improvements in VO2 max, muscle hypertrophy, strength, or other fitness markers. And rapid adaptation to training stimuli is often possess genetic variations that favorably influence physical performance. Yeah. And we can often see this in the gym, or if you're coaching people, there's always be people who like to have this rapid adaptation to training stimulus, and those who are a little bit slower. Yeah. And you could give those people the same exact program and it'll be evident. So low responders definition: individuals who experience minimal to no significant improvements in performance metrics despite following the same exact exercise program. Characteristics: smaller or negligible gains in fitness markers, slower or less pronounced adaptation to training stimuli. So it may possess genetic variations that do not favor rapid or significant improvements in physical appearance. This doesn't mean these people won't see improvements. It's just going to be a slower process, right? And there has to be more determination there, more discipline, and in most cases, more effort, unfortunately. And you've got to do it for longer compared to a high responder, yeah? And again, another graph here showing that people with really bad genetics who gain muscle half as fast as people with average genetics, yeah? Some people are going to fall into this space. People with bad genetics who build muscle about 10 to 20% slower than people with average genetics. And then you have the average cohort who gain muscle about as fast as you'd expect, right? And how fast can you grow muscle is something I'm going to explore later, yeah? So we'll get to that bit. So people with good genetics who build muscle 10 to 20% faster than people average, and then also you have your elite down this side of the bell curve, yeah? So high responders may experience a greater increase in satellite cell proliferation during training versus low responders. This phenomenon could serve to maintain an adequate myonuclear domain size or assist in extracellular remodeling to support myofiber growth. So what is a satellite cell? Yeah, so this is part of the muscle that we're going to explore now, or in a minute. Okay, so factors influence in response to training. So let me just go back quickly. So this satellite cell proliferation, I'm going to explore that in a minute, but we'll just get through this last bit, yeah? Okay, so factors influence in response to training. Genetic variability, and we've gone through the main players, being ACTN3 gene, the ACE gene, and the PAR1 gene. So variants in the ACTN3 gene influence muscle fiber type composition, the R578X polymorphism, where the R alleles associated with power and speed can make some individuals more responsive to strength and power training. The ACE gene, the I/D polymorphism is in this gene is associated with endurance performance, with the I allele linked to higher endurance potential. Yeah, so the a good example of that is sprinters, powerlifters, weightlifters, compared to like people who want to do like long endurance runs, ultra marathons, and like Ironman type activities, yeah, or sports. Obviously, you're probably going to have some genetic freaks in there who are probably good at both, unfortunately. But for the most part, I think most people gravitate towards one or the other in terms of their genetic makeup. So variants in the PAR1 gene affect mitochondrial biogenesis and energy metabolism, influencing aerobic capacity, endurance training response. And literally, your genetics will determine how well you can perform aerobically. Not to say that you can't get better aerobically if you train cardio, everyone can, but there's always going to be people who will respond incredibly well to it and surpass everyone else. Yeah. Okay, carrying on. Factors influencing response to training. Epigenetic factors. Gene expression can be altered by environmental factors, including physical activity. These changes can enhance or reduce an individual's responsiveness to exercise. So if you think you are in the middle to low responder side doing nothing isn't going to help, right? On the contrary, that will make it worse because you're not adapting to anything. But employing regimented, consistent, and effective programming can and will help you reap rewards. Yeah, especially if you're on the middle to low responder side, you have to do more. You have to be consistent with it, and you have to employ effective programming. Yeah. The most interesting part is that you can develop your nervous system and gene expression. These adaptations then get passed on to your children. If we follow this progression through generations, the next steps would be to ensure your children get into sports from an early age. Personally, I would say from about 5 years old, very latest. They then can have 10 years to enhance physical traits, motor patterning, nervous system adaptations, and gene expression, and thus passing these higher level adaptations on to their children. Yeah. So this is an area where a lot of people fall into a hole with and they don't understand it. Get into the gym, train, pass on some good genetics to your children, get them to train from an early age. Their gene expression is gonna improve, their motor pattern is gonna improve, they're gonna pass on even better genetics to their children. Yeah? This has to be something that you think about and do. This is something I see all the time in clients. Those whose parents didn't take part in sport or didn't look after their physical health well are often less developed in terms of responsiveness to exercise and motor skills. Furthermore, this often is a trait in women who have avoided sports. They have negligible motor skills just generally in life. It's also not too late, right? If you are not active, go to the gym regularly, enhance your physical skills through strength and or take up a sport, ideally a ball sport with a team aspect to it. Yeah. It's one thing taking up an individual sport like tennis, but taking up a more advanced sport, in my opinion, like football or basketball or a team environment with a ball where you have to always be analyzing the field, right? Not just yourself, but the opponent, your teammates, how everyone's moving around, what traits people have. Yeah. You have to understand your teammates. What are they likely to do? If you have a teammate who's, let's say, for example, in football, in my experience, let's say you have two guys on your team. One guy likes to hold on to the ball and he likes to run with the ball. Another guy doesn't like to hold the ball. You know that when he gets the ball, he's going to release it quite quickly, right? You can then determine where you're going to place yourself on the field in respect to that person. And you only develop these skills through sport. It's very hard to develop these skills in any other area in life. Yeah. Not to say that you can't develop those skills within like a sport like tennis, but there's only one other person, right? Unless obviously you're doing pairs and doubles and stuff, but usually it's like 1v1, right? And there's less thought going on there. There's less planning. There's less spatial awareness because there's only one person versus one person, whereas a football pitch is 11 versus 11. Like you've got to think about a lot of stuff when there's that many people on a pitch and there's only one ball and there's only two goals. Yeah. So obviously analyzing other people's movements and traits, positions, timing of movement, and time of the ball movement, it all creates a far superior motor skill intellect. Yeah. So get into sport. And even if you're a woman and you're not really into sport, there's sports you can do that are not that like strenuous. Volleyball, badminton, tennis, hockey, what's the other one? Netball. They're all very good sports you can take up. Yeah. Once a week is great. Okay, moving on with factors influencing response to training. So training variables. Type of exercise, intensity and volume, non-genetic factors, sleep and recovery, physical, psychological factors. These all factors that influence training. They have nothing to do with your genetics, right? So different types of exercise, strength versus endurance can elicit different responses depending on genetic predispositions. Intensity and volume. High responders may benefit more from specific intensities and volumes of training, while low responders might need alternative approaches or more personalized programs. Non-genetic factors, nutrition, dietary habits, and nutrition intake can significantly influence training outcomes. I can't stress this enough. Yeah. Especially if like you're a middle to low responder, you can't get away with like a poor diet. Sleep and recovery. Adequate rest and recovery are crucial for optimal training adaptation. And obviously, psychological factors, motivation, stress levels, and mental health can affect how well someone responds to exercise. Okay, as I said earlier, let's dig into satellite cells. So you can see the images on the right. Satellite cells play a crucial role in the body's response to training, particularly in muscle and growth and repair. Okay. What are satellite cells? Satellite cells are a type of stem cell found in skeletal muscle tissue. They are located between the basal lamina and sacrolemma muscle fiber membrane of the muscle fibers. Satellite cells remain in a quiescent inactive state until they're activated by stimuli such as muscle injury or intense exercise. Yeah. And we can see where those are in the muscles. Okay. Activation and function of satellite cells. So if you don't activate them, they're not going to do anything. Yeah. There needs to be some sort of stressor there. Okay. Just getting a bit warm again, guys. Let me just open this up. Hopefully we're good for outside. Muscle damage and repair. Activation. During exercise, especially resistance training or high intensity activities, muscle fibers experience micro damage. This damage activates satellite cells. Proliferation. Once activated, satellite cells proliferate, which means multiply, and then differentiate, mature into myoblasts, precursors for more muscle cells. The fusion, these myoblasts fuse with the existing muscle fibers, donating their nuclei to the muscle cells. This process is essential for muscle repair and growth. And obviously muscle hypertrophy, which is growth, involves increased nuclei and muscle fiber enlargement. The fusion of satellite cells with muscle fibers increases the number of nuclei within the muscle cells. Since each nucleus controls a specific volume of cytoplasm, more nuclei allow for greater protein synthesis capacity, leading to muscle hypertrophy. And muscle fiber enlargement. As protein synthesis increases, muscle fibers grow larger, resulting in increased muscle and strength. Yeah, so that's literally what muscle hypertrophy is, the full breakdown or a concise breakdown. Adaptation to training, enhance recovery and improve muscle function. Satellite cells help repair damaged muscle fibers, allowing for quicker recovery between training sessions. This enhanced recovery contributes to more effective and sustained training adaptations and improve muscle function. By repairing and growing muscle fibers, satellite cells contribute to improved muscle function, endurance, and overall performance. Right, genetic influence on satellite cell activity. Different individuals have varying levels of satellite cell activity and responsiveness due to genetic differences. This variability can partly be explained by why some people experience significant gains from training high responders, while others see minimal changes in low responders. Key genes involved are the PX7 and the myostatin. So a critical gene, the PX7, for satellite cell maintenance and proliferation. Variations in the expression or function of the PX7 can influence the pool of available satellite cells. Yeah, and myostatin, a gene that inhibits muscle growth. Lower levels of myostatin activity to lead to higher satellite cell activation and muscle growth. And obviously mutations in the myostatin gene can result in increased muscle mass. But obviously, as we explored earlier, there's trade-offs for that, right? You can't just have high myostatin levels, low myostatin levels, and then no trade-offs there. Factors influencing satellite cell activity. So age, exercise type, intensity, nutrition, hormonal influence. So all of these factors can influence satellite cell activity, right? And we need to consider these if you're like a middle responder or a low responder, more so than you would for a high responder. As people age, the number and activity of satellite cells tend to decrease. This decline contributes to age-related muscle loss, which is called sarcopenia, and reduced ability to recover from exercise. And there's one key area why, as you age, you need to increase protein intake, to facilitate and help this process not be as damaging or poor. Exercise type and intensity. Resistance training and high intensity exercise are particularly effective at activating satellite cells. Endurance training can also activate satellite cells, but generally to a lesser extent than resistance training. Nutrition. Adequate protein intake is crucial for satellite cell function and muscle repair. Certain nutrients such as amino acids, especially leucine, play a significant role in stimulating satellite cell activity and muscle protein synthesis. Hormonal influence. Hormones such as testosterone, growth hormone, and insulin-like growth factor, which is IGF-1, can enhance satellite cell activation and muscle growth. Okay, so these are some factors we can consider and look at improving or optimizing to influence satellite cell activity and upregulating it. So what are some practical implications we can apply, right? Okay, so looking at training programs, recovery, nutrition, age-related considerations, and nutritional strategies, right? So training programs incorporating resistant training exercises can maximize satellite cell activation, promoting muscle growth and strength. Periodizing training, varying the intensity and volume can help sustain satellite cell activity and muscle adaptation over time. And looking at recovery and nutrition, ensuring adequate recovery time between workouts and consuming a protein-rich diet can support satellite cell function and muscle repair. Post-exercise nutrition, including protein and carbohydrate intake, can optimize satellite cell response and muscle recovery. So age-related response considerations, and obviously older adults may benefit from resistance training programs specifically designed to counteract the decline in satellite cell activity and muscle mass. And it's even resistance training is even more important for older adults due to this decline in cell activity and muscle mass loss that happens with aging. Including protein supplementation and possibly hormone replacement therapy, obviously under medical supervision, may help maintain muscle mass in older populations. Yeah. Okay, let's dig into the fun part. How much muscle can you gain? Right, there is evidence to support the notion that high responders to exercise tend to have a higher number of satellite cells. Several studies have investigated the role of satellite cells in muscle hypertrophy and the variability in individual responses to training. Research evidence. So variation in satellite cell density. So study by Petrella et al. This study investigated the relationship between satellite cell number and hypertrophic response to resistance training. They found that individuals who exhibited a greater hypertrophic response, so high responders, had a higher baseline number of satellite cells compared to those with a lower hypertrophic response. Low responders. Moreover, high responders also showed a significant increase in satellite cell number following training. Crazy. And obviously with the abstract there, we can highlight that individuals with a greater basal presence of satellite cell demonstrated with training a remarkable ability to expand the satellite cell pool, incorporate a new nuclei, and achieve robust growth. It's almost unfair, isn't it? Okay. Genetic influences on satellite cells. Study by Schneider et al. This study found that genetic factors significantly influence the number and activation of satellite cells. They highlighted that individuals with a genetic predisposition for greater muscle growth tend to have a higher satellite cell count and more robust satellite cell activation in response to training. Yeah. Obviously, baseline satellite cell number. High responders typically have a higher baseline number of satellite cells in their muscles, and high responders with satellite cell proliferation exhibit greater proliferation in response to muscle damage and training stimuli. Okay, looking at personalized training programs. So understanding the role of satellite cells can help in designing personalized training programs. For example, individuals identified as low responders may benefit from different training protocols, such as varying the intensity and volume or incorporating more recovery time to maximize satellite cell response. Looking at nutritional support adequate protein intake and nutritional strategies that support muscle repair and growth can be particularly beneficial for enhancing satellite cell activity and improving training response. Yeah. So there's always these things we can do to improve the environment. Age-related training. Older adults may have reduced satellite cell pool and proliferative capacity. So resistance training and specific nutritional interventions can help mitigate age-related declines in satellite cell function and muscle mass. So exactly how much muscle can you gain? The big question. The amount of muscle an individual can gain varies widely based on several factors, including genetics, training regime, nutrition, age, sex, and overall health. However, research and expert opinions provide some general guidelines on muscle gain potential and the factors that influence it. All right, let's dig into it. General guidelines for muscle gain. Initial gains and intermediate to advanced lifters. We have periods here. And we have the diagram on the right, outlined by Alan Aragon. Yeah, I said that right. Initial gains. Beginners, people new to resistance training often experience rapid gains in muscle mass known as newbie gains in the first year of consistent training. And I must highlight that has to be like good, effective training. If you're just farting around in the gym, nothing structured, then you're not going to get the most gain you can within that first year. And we tend to see there's quite a lot of newbies want to figure it out, but they just waste time. Yeah. If you're a newbie, get a coach because you'll speed this process up even more. Beginners can expect to gain about 1 to 1.5% of their body weight in muscle per month. So an example of that is a 70 kg beginner might gain approximately 0.5 to 1 kg of muscle per month initially. And then intermediate to advanced lifters, so after initial gains, the rate of muscle growth slows down. Intermediate lifters might gain around 0.5 to 1% of their body weight in muscle per month. And then advanced lifters with several years of consistent training, will experience further slowing in muscle gain. They might gain only 0.25 to 0.5% of their body weight in muscle per month. And this is obviously expressed in Alan Aragon's graph here. Yeah. And then obviously we want to try to reach genetic potential. But as you start, things speed up and it slows down. All right. Looking at some research findings. So yearly gains. Alan Aragon's model, a widely cited model by fitness expert Alan Aragon, provides estimated yearly muscle gain for men and women based on training experience. Obviously, year one of it is express. Men can gain 9 to 11 kg of muscle. Women can gain about half of that amount. Yeah. Year two, men can gain 4.5 to 5 kg of muscle. Again, women half of that. Year three, 2.3 to 2.7. Again, women half of that. And then year 4 plus, gains continue to diminish with men gaining about 0.9 to 1.4 kg of muscle per year. And again, women gaining about half of that. Yeah. So that is the research finding on how much muscle you can grow over that period of time. And if you're in this year 1 to 3, like you've got to stop fucking around, man. Just get a coach, get someone who's experienced, knows what they're doing, help you just blast through this period of time really quickly. Yeah. That's a crucial time for someone training. And obviously on the right here, we have a diagram expressing how the muscle gain slows down over time as you become more advanced. Yeah. And we have this quick speed up when you're a beginner. Okay. So what are the genetic limits? Studies on genetic potential. Research by Corey et al. 1995 estimated that maximum fat-free mass index, FFMI, for natural bodybuilders is around 25 for men. This provides a rough upper limit for muscle mass, though individual genetic potential may vary. Yeah. The fat-free mass index is a great tool we can use to figure out if we have reached genetic potential and or if another person has used PEDs, which is performance enhancing drugs. I will leave the link in the description, but you can also just Google or search FFMI calculator to figure out where you are on that scale. If you've reached genetic potential, or how close you are, or how far away you are. Yeah. And obviously on the right here is the study, the normalized FFMI values of athletes who had not used steroids extended to a well-defined limit of 25. Yeah. And that's what we need to say there. Yeah. Obviously expresses that some steroid users in our sample exceeded 25 and some exceeded 30. Yeah. FFMI. And that's also indication of how to spot drug users, performance enhancers. Let's mute that. So looking at my own data, which was taken 29th of June, 2024, on the right here, I can let the video play of my current condition as of June, 94 kg at the time. We can see I have basically reached my genetic potential in terms of muscle mass growth, it would seem. Yeah, personally, my own goals at the moment don't really orientate around gaining more muscle mass anyway, but more so remaining healthy and fit, plus a high functioning cardio system, remaining athletic, becoming leaner, but also maintaining muscle mass and increasing strength where possible. So for me right now, I want to try and be as athletic as possible in my current condition. And if I can push myself down towards 90 kg, that would be great. But I don't have any like goals to put on more muscle mass. More so be athletic, be cardiovascularly fit, aerobically fit, or fitter than I am now. Maybe be a bit lighter and increase my strength more so, and my skill in that respect. Yeah. So inputting my data into the calculator, 181 centimeters, I'm male, 94 kg, body fat 16.8 at the time, and my FFMI fat-free mass indicator is 24. Yeah. And the upper limit is 25. 25? Is that right? Yeah, 25. Yeah, upper limit 25. So I'm basically there. And actually, that's taken me, when I started training, probably 15 years ago. Yeah. And your result is classified as superior. Thanks, bro. All right, moving on. Make sure I don't skip anything. All right. So what are the factors influencing muscle gain limits? Genetics, hormones, age, training, and nutrition. Genetic predisposition. Some individuals are genetically predisposed to gain muscle more easily due to factors like muscle fiber composition, hormone levels, and satellite cell activity. Hormones, testosterone and growth hormone. Higher levels of anabolic hormones like testosterone and growth hormone can enhance muscle growth. Men generally have higher levels of these hormones than women, contributing to greater muscle gain potential. So age, younger individuals tend to have higher potential for muscle gain due to more favorable hormone profiles and recovery capacity in your earlier years. And obviously, as individuals age, muscle gain potential decreases due to factors like reduced hormone levels, slow recovery, and decreased satellite cell activity. Looking at training and nutrition, consistency and intensity, regular progressive resistant training and appropriate exercise intensity are crucial for maximizing muscle gains. Adequate protein intake is essential for muscle repair and growth. The recommended intake for muscle gain is a minimum of 2.2 grams of protein per kilogram of body weight per day. And that is to optimize your potential to grow muscle and increase satellite cell activity. Less than this is not good enough. Yeah. We can also use the Casey-Butts test if we're wondering about what our genetic limit is. Dr. Casey Butt, a PhD and researcher in the field of natural bodybuilding, has delved deep into this subject, analyzing approximately 300 natural bodybuilding champions spanning from 1947 to 2010. His groundbreaking work provides valuable insights into predicting one's potential, lean body mass, and understanding the timelines for achieving maximal gains. Dr. Casey Butt has not only provided a foundation for estimating overall lean body mass potential, but has also extended to specific muscle groups with comprehensive analysis that incorporates measurements for the neck, the chest, bicep flex, forearm flex, thigh, and calf, which offers a more detailed understanding of individualized growth. So what are some practical implications and realistic expectations? Realistic expectations. It's important to set realistic expectations based on individual differences. While some may achieve the higher end of muscle gain potential, others might see slower progress due to genetic and lifestyle factors. What are the long-term perspectives? Muscle gain is a slow, gradual process, especially after the initial rapid gains. Consistency over months and years is key to achieving significant muscle mass. Monitoring progress. It's important to track progress through measurements, strength gains, and visual assessments, which can help individuals stay motivated and adjust their training and nutrition plans as needed. Right, what are some practical tips if you are a low responder? So before I go on to diving into practical tips, if you are somewhere in the middle or a low responder, then it's important you understand to truly succeed, you need to make it your lifestyle, right? You must seek mastery in enhancing your physical fitness and health. Also, if you've never had coaching and you've just been flapping around in the gym for years, then you don't really know if you're a low responder or a high responder because you probably haven't done anything really effectively yet. Yeah, for the most part. That's my perspective from working in the gym for like almost 2 decades. Yeah. To do so, first requires adopting an apprentice mindset. I'm going to use some quotes from a book I've been reading recently by Robert Greene called Mastery to highlight the ideas in this area because so many people want the results but don't want the work. And this is why like surgery is so popular amongst like women and belly jobs, BBLs, etc. Right? It really doesn't work that way. Like especially if it doesn't come easy as you like. If you're more genetically, it doesn't come that way easily, like more genetically gifted individuals, right? So looking at the book, the quotes that I've pulled out for you guys, skills acquisition, the practice. Every human activity, endeavor, or career path involves the mastering of skills. Skills are more nebulous, such as handling people or researching and organizing information. So in some fields, it's direct and obvious, like operating a tool machine, creating something physical. In others, it's more of a mix of the physical and mental, such as observing and collecting specimens for Charles Darwin. In still others, the skills are more nebulous, such as handling people or researching and organizing information. As much as possible, you want to reduce these skills to something simple and essential, the core of what you need to get good at. Skills that can be practiced. Yeah, and we see this in training a lot where people are trying to do too much. Yeah, get to the core of it, get good at those core skills, and then you can develop further from there. In acquiring any kind of skill, there exists a natural learning process that coincides with the functioning of our brains. Called tech knowledge, a feeling for what you are doing that is hard to put into words, but easy to demonstrate in action. And to understand how this learning process operates, it's useful to look at the greatest system ever invented for the training of skills and the achievement of the tacit knowledge. The apprenticeship system of the Middle Ages, in which young people from approximately the ages of 12 to 16 would enter work in a shop, sign on a contract that would commit them for a term of 7 years. At the end of this term, apprentices would have passed a master test or produce a master work to prove their level of skill. And this is like similar to training, sport. You have to be an apprentice, you have to find a mentor, and you have to practice for a long time. Yeah. Okay, I need to read that bit. Okay, so looking at the natural model for learning came from watching and imitating others, then repeating the action over and over. Yeah, our brains are highly suited for this form of learning. Really important. We're also looking at this here because a few books or drawings existed at the time. Apprentices would learn the trade by watching masters and imitating them closely as possible. They learn through endless repetition and hands-on work with very little verbal instruction. If one added up the time that apprentices ended up working directly on materials in those years, it would amount to more than 10,000 hours, enough to establish exceptional skill at the craft. Yeah, you've got to put your 10,000 hours in. Yeah, if you're a low responder, if you want to get good at it, if you're a medium responder, you've got to put the hours in. Yeah. Okay, last one. Once something is repeated often enough, it becomes hardwired and automatic. This process of hardwiring cannot occur if you are constantly distracted, moving from one task to the other. Once an action becomes automatic, you now have the mental space to observe yourself as you practice. You must use this distance to take note of your weaknesses or flaws that need correlation to analyze yourself. It also helps to gain as much feedback as possible from others to have standards against which you can measure your progress so that you're aware of how far to go. Trying something over and over again grounds you in reality, making you deeply aware of your inadequacies and of what you can accomplish with more work and effort. If you take this far enough, you will naturally enter the cycle of accelerated returns. As elements become more automatic in your mind, it's not as exhausted by the effort and you can practice harder, which in turn brings greater skill and more pleasure. You can look for challenges in new areas to conquer, keeping your interest at a high level. As the cycle accelerates, you can reach a point where your mind is totally absorbed in practice, entering a kind of flow in which everything else is blocked out. You become one with the tool or instrument or thing you are studying. Yeah. In essence, when you practice and develop any skill, you transform yourself in the process. Your sense of pleasure becomes redefined. What offers immediate pleasure comes to seem like distraction and empty entertainment to help pass the time. Real pleasure comes from overcoming challenges, feeling confident in your abilities, gaining fluency in skills, and experiencing the power this brings. 10,000 hours generally adds up to 7 to 10 years of sustained solid practice, roughly the period of a traditional apprenticeship. In other words, concentrated practice over time cannot fail but produce results. Can you take criticism and use it constructively, right? And also, if you're trying to excel in your physique, your performance, lose weight, you have to put the time in. You have to be about the process and not just about the outcome. Yeah, if you're just about the outcome, you won't find any pleasure in it. All right, practical tips if you are a medium to low responder. Optimize your training. For middle to low responders, achieving muscle growth and strength gains will likely require a more tailored and strategic approach to training, nutrition, and recovery. Whereas fast responders could probably hop on any generic program and seek gains, this likely won't work for many of those in the middle to low side of the scale. Training tips. Quality exercise is paramount. Ensuring reps are of high quality to create as much stimulus and return on time investment is incredibly important. Focus on developing technique to a high level and opting for full range of motion on all exercises to take muscles and joints to the full stretch positions and end ranges. Prioritize strength stimulus and hypertrophy modalities layered on top. Mechanical tension, strength stimulus, has the greatest potential for developing muscle fibers, especially fast twitch muscle fibers, and overall strength and bone density. Increased bone density signals to the body to reinforce connective tissue and attach more muscle. Include an adequate moderate cardio to improve cardiovascular system and health. Yeah. Okay, carrying on to progressive overload with our practical tips. Training volume and frequency and exercise variety. Gradual increase for progressive overload. Consistently increase the weight, reps, or intensity of your exercises to continually challenge your muscles. Tracking progress. Keep a workout journal to track your progress and ensure you are steadily increasing the difficulty of your workouts in some way, shape, or form. Higher volume. For training volume and frequency, incorporate a higher volume of training, more sets and reps to provide sufficient stimulus for muscle growth, right? Whereas a high responder might get over low volume, if you're medium to low, you might need to push towards higher volume, yeah? And increase frequency. Train each muscle group 2 to 3 times per week to ensure frequent stimulation and allow for adequate recovery. Exercise variety. Compound movements. Focus on compound movement first, e.g. squats, deadlifts, and bench presses that target multiple muscle groups. That's priority. Then we can add in isolation exercises to specifically target lagging muscle groups and ensure balanced development. Looking at intensity techniques, we can use drop sets, supersets, rest pause, incorporating intensity techniques to increase the time under tension and muscle fatigue. Periodization, cycling through different training phases, for example, hypertrophy, strength, endurance, to prevent plateaus and keep the muscle adapting. Spreading these phases across each session is also a tactic, as well as biasing certain modalities at different periods of time. Okay? And this is why it's important to get a coach, or it's important to utilize progressive programming, tailored programming, so you can manipulate all of these variabilities to improve your ability to grow muscle, get the physique you want, lose the fat, get lean, get stronger, especially if you're a medium to low responder. Optimize your nutrition. Adequate protein intake, protein amount. So aim for 2.2 to 3 grams of protein per kilogram of body weight. Obviously, if you're an older adult and a male, then you need to be on this higher side. Yeah. Protein timing, distribute protein intake evenly across meals to maximize muscle protein synthesis. Generally, caloric surplus, or looking at energy balance. Consume a slight caloric surplus, 10 to 15%, to support muscle growth without excessive fat gain. This, however, does depend on your current body composition. Utilizing a moderate caloric deficit of 10 to 15% if body composition needs improving via fat loss can also work if you keep protein intake very high. Yeah. Focus on nutrient-dense foods, especially high-protein animal sources. Focus on nutrient-dense foods like red meat, organ meats, fish, poultry, eggs, and dairy. Ensure optimal micronutrient and fiber intake is maintained by consuming plenty of fruit and vegetables as well. Yeah. Post-workout nutrition. Protein and carbs. Consume a post-workout meal or shake containing both protein and carbohydrates to replenish glycogen stores and support muscle growth. Stay well hydrated throughout the day to optimize performance and recovery. And that is how to optimize your nutrition, especially if you're a medium to low responder. Now looking at optimizing recovery and active recovery. So ensure your adequate sleep. Aim for 79 hours of quality sleep per night to support muscle recovery and overall health. Sleep hygiene. Maintain good sleep hygiene by establishing a regular sleep schedule, creating a relaxing bedtime routine, and minimizing exposure to screens before bed. Remove screens from the bedroom. Remove your phone from the bedroom. Yeah, you've got to improve the environment for you to sleep well. Just remove the screens, remove the phone. And that will improve your sleep quality substantially and reduce your anxiety around to-do lists and sleep generally. Active recovery, light activity, foam rolling massage, rest days, deload weeks. These are all things we can do to improve recovery. Incorporating light activities such as walking, yoga, or stretching on rest days to promote blood flow and aid recovery is also a good idea. Use foam rolling or get massages to help alleviate muscle soreness and improve tissue quality. Ensure you have enough rest days in your training program to allow muscles to recover. And obviously implementing deload weeks, reduce training volume and intensity every 4 to 8 weeks to prevent overtraining and facilitate recovery. But that is all. That deload section it depends on the person, how hard you're training, lifestyle, commitments, and it's worth discussing that with your coach or implementing sort of like deloading within the programming. Okay, looking at supplementation tips. We can look at creatine monohydrate to performance boost. So creatine has been shown to enhance strength, power, and muscle mass. So looking at a dosage of somewhere between 3 to 5 grams per day. Looking at protein supplements, which is good for convenience. Use protein supplements, whey, casein, or plant-based proteins if you are plant-based to help meet daily protein requirements, especially if it's challenging to get enough protein from whole foods alone. Other supplements we can look at are BCAAs, which can be useful to reduce muscle soreness and support recovery, particularly if training fasted or with low dietary protein. and vitamin D and omega-3 fatty acids are important for overall health and potentially enhancing muscle function and recovery. Yeah, so these are some very important supplements we can add in. Yeah. Looking at monitoring and adjusting. So regular assessments is key. Track body measurements, strength gains, progress photos to objectively assess muscle growth. And based on progress, adjust training intensity, volume, and nutrition as needed to continue progressing. Okay, final message as we wrap it up. I hope you've enjoyed that. Let me know in the comments, likes, subscribes, stuff like that. If you have any questions, let me know. But my final message, personalization is key. All right, individual response. So recognize that individual responses to training and nutrition vary. What works for one person may not work for another. However, applying proven sports science frameworks can keep you on the path to success, right? Professional guidance is key. Consult experts. I strongly recommend working with a coach or a certified personal trainer or nutritionist to create a personalized plan tailored to your needs and goals. Working with a coach has been proven time and time again to increase chances of success. Do research, look at the coaches' testimonials, look at their clients and how they train and the results they get. Review the coach's internet trail, websites, blogs, social media, and review their philosophies around training. Also review the coach's physical condition. Do they lead by example and embody what they want to achieve? Yeah. By incorporating these strategies, low responders can optimize their training, nutrition, and recovery to enhance muscle growth and achieve their fitness goals. Right, thank you for watching and spending your time with me. If you have enjoyed this video, please give it a like, a comment if you have any, or if you have any questions, drop a comment below, and hit the subscribe button if you're not subscribed already for future content like this. Okay, have a great day, guys. Bye.